Hi everyone, welcome to week 5. Just to recap, so far we have talked about HTML, CSS, as well as JavaScript and TypeScript, a little bit of practice on writing functions relating to TypeScript and JavaScript, and hopefully you get a good understanding of why we prefer using TypeScript as well as the different types within TypeScript. So now that we talked a bit about front end, we'll start diving deep into how the backend works and how it's all connected, which is why we're starting with APIs and Node this week. Okay, so to take a look at the data flow diagram that we have been referencing throughout the semester over the past 4 weeks. So on the top left corner, you can see HTML and CSS along with React, which we will be beginning to learn next week. After that, we focused on JavaScript and TypeScript. And now we're starting with the pink circle that you see at the mid section, which is APIs. We will talk more about what REST APIs in detail a little bit towards the end of the semester. But yeah, just to give you a look of how everything has started to take form. So what exactly is API? API is an application programming interface. Now, to understand what an interface is, it's basically your front-end interaction with the application. So a user uses an interface in order to get some data or send data. It's basically everything that the user can see and interact with on the screen. It is exposed to different kind of endpoints and channels where the data is passed. And these endpoints are the things that are connected to the backend services. So you can view an interface in the same way as a JavaScript function. Well, not exactly the same way, but I would say it is analogous to it. So it accepts some input parameters and then returns an expected output. You can think of it in reference to the analogy of a waiter in a restaurant. Imagine you're at a restaurant and you, as the client, want to order some food. But you don't go directly into the kitchen and ask the chef to make it yourself, right? Instead, you tell the waiter, which could be thought of as the API or the endpoints that help you select from the menu, which is the available services relating to the API, and then the waiter takes your order and then goes to the kitchen, which in this case would be the server, and then the kitchen prepares your food and waiter brings it out to you. So let's take an example of a Twitter API. Let's say you're interacting with the Twitter API for some reason, and you want to get information about a person's profile. In order to do that, you would need to use an API endpoint that takes in your user ID and then returns data about the user. Most likely, you will always be using GET, the HTTP request of type GET, because we're trying to get information from Twitter API into our website and not trying to post anything there. If you were to create custom APIs in the future for your web applications, then you will likely also use a post request. And to add on to that, so we earlier used the example of a waiter in a restaurant. So in order to continue with that example, let's say endpoints could be thought of as specific stations in the kitchen, right? So you would have different kind of stations, a grill station, a salad station, or the dessert station. So when the waiter, which is the API, takes your order, they know exactly which station to send each part of your order to, and the station in this case would be an endpoint. Let's say the request was for a salad. Then it goes to the salad station. The steak order goes to the grill station, and the dessert order goes to the dessert station, and so on and so forth. So each point, aka station, specializes in a certain task and returns the prepared dish. The dish would in this example be data, back to the waiter, which is again the API, who then serves the complete order to you, which is the customer as a client. We'll just go and continue using this analogy throughout this video. So just try and remember that the API is the waiter, the client is you, the customer in the restaurant. The data is the food or the dish that is getting prepared. The kitchen is the server, and then let's say the different kind of stations in the kitchen are the endpoints. So server versus client. So there's two sides of applications, a server-side application and a client-side application. So the server-side of application could be thought of as the kitchen where all the cooking and heavy preparation is done behind the scenes. It runs separately from the client-side application, and it often runs over a remote server or computer that the user does not often have direct access to. So it is built to serve data for clients to use, and this is where API endpoints and APIs are used. On the other side, client-side applications are used to deliver and render on your personal computer. They are built to display data to the user. So if we again think about the kitchen example, you as the customer, aka client, doesn't know what's going on in the kitchen at the back behind the scenes. You just ask and expect for the result. You don't know what recipes the chef is using, you don't know anything. You just order a steak and then expect a steak to just come out. So imagine you place an order for a complex dish like a multi-course meal, which would again be a data request. Then the kitchen, which is a server side, prepares everything, including cooking, presentation, garnishes, and everything, and then creates this dish, and then the waiter, which is again the API, brings it out to you as the client. Versus for a client-side application, the things would work a little differently. So let's say client-side application would be analogous to thinking that you go to a cafe that has its own salad bar, that you get up and you create your own salad at the bar. And it has all these ingredients available, and you do the preparation and the assembly yourself. At the salad bar, you as the client are responsible for picking your own ingredients and creating your own dish. The restaurant only provides the raw materials, which is the data. So we talked about async a bit in last class, and I hope that with this class, what async does and how it's exactly used hopefully becomes a little bit clearer. So as we discussed, server applications don't run locally, right? You need to talk to them over the internet in order to get information from them. So once a request for something has been made in order to fetch that information from the server, we don't know how long it usually takes. It could take a couple of seconds, it could take a couple of minutes, but we don't want the background information, the background processes to stop while we get the information, which is where asynchronous functions come in handy. So JavaScript can continue running, and when the server gets back to us with the incomplete information that we were waiting on, the asynchronous callback can handle the result. So using async is kind of similar to how a waiter doesn't stand around waiting for you to order or your food. So how the waiter doesn't, I messed that up, sorry, excuse me. So how the waiter doesn't, so using async is similar to how a waiter doesn't stand around waiting for your order to be prepared by the kitchen. They go around taking orders from other customers until yours is prepared. If you didn't add async, everything would be synchronous and would exhibit blocking behavior, meaning the waiter would just be standing at your table, staring awkwardly until your order is ready, and we don't want that. Nobody wants that. So imagine you make requests to fetch data from a server. It might take time for the server to respond. With async, JavaScript can continue running other tasks like rendering a button or updating a part of the page while waiting for the server's response. There's also something called promises that we will touch a bit later, but just to give you a high-level idea, so everything connects and makes sense. A promise is like the waiter assuring you that your main course will be ready at some point. Okay, so the last thing that we have in this pre-work are HTTP requests. So we talked a lot about like interacting with an API, but how do you do that? There needs to be a language in order to do that, right? So that is what HTTP is. HTTP request types specify how to format API requests, meaning so that the API knows whether you're putting info in or you're getting info out or just updating info that already exists on the server. So there's three main types: get, post, and put. So the get request is used in order to retrieve information from a particular source, which is something that you will be using more often than not. Let's say you want to get information about a user's ID, then you would use the get request. Versus a post request is used to submit data to a particular destination. So let's say, to take an example of Instagram, right? If you worked at Instagram and then somebody is posting a new post, then a new post to Instagram feed would be handled using a post request. A put request is quite similar to post request, but it's rarely ever used because it's usually a request to post an entire file, basically overwriting everything that was there earlier. There's very few use cases where using a put request actually makes sense. So the last thing for this pre-work that we want you to do is just set up Postman. You can either install Postman on your laptop or use the web version. It's totally up to you. We'll talk more about why we're using Postman and what we're using it for in class when we have you do the first exercise. So hopefully it all connects and makes sense. It's relating to like API endpoints and getting a good understanding of HTTP requests. And if you have any questions from this pre-work, make sure to note them down and we will go over them in class. Enjoy the rest of your week.